Okay, so we're going to be solving logarithmic equations. We're going to start with the property of equality just to kind of go over it. So if we have something such as log base b of x equals log base b of y, notice how they both have base b, okay? So that means x has to equal y. This only occurs if the base is the same. So for example, if you have log base 2 of x, which equals log base 2 of 7, since they both have a base of 2, then x equals 7. Okay? If you have a base with the exponent that is a log that has the same base, then whatever is inside those parentheses is your answer. Okay? So we have some general steps here. Basically, you're going to rewrite the problem only using one log on both sides of the equation sign, okay? But secondly, we're going to rewrite the problem without logarithms. So for example, if you have two logs, you're going to use the equality property. But if you have one log, you're basically going to change it to exponential form. We'll simplify it, solve for x like we did in Algebra 1, okay? And we need to check the answers because we cannot take the log of negative numbers. So for example 1, we have natural log of 4x minus 7 and natural log of x plus 5. Remember, natural log has the same base e. So basically what we're going to do is have 4x minus 7 equal x plus 5. And we have an algebraic equation there. So we're going to get the x's to one side and our constants on the other. Because I don't want a negative x, I'm going to subtract this x. And I'm left with 3x minus 7 equals 5. That's gone. Okay, and then I'm going to add the 7 over, which gives me 3x equals 12. And when I divide away the 3, x is equal to 4. So we need to check that this 4 is not going to give us a negative number. Okay, so if I go back to my original, I have natural log of 4 times 4, which is 16, minus 7. Okay, because I'm plugging in 4 here. Okay, and that is not a negative number, so that's good. That's actually 9. And over here I have 4 plus 5, which is also 9. So it is a good solution. Moving on. We have the log base 2 of 5x minus 7, which equals 3. This is what I was talking about. If you only have one log, we need to change it to exponential form. So notice how when I'm reading it, I say log base 2. That is my base, so 2 is going to be the big number. Of 5x minus 17 equals 3. 3 is my exponent, so 2 to the third power equals 5x minus 17. Okay, well, now you have to plug in 2 to the third power in the calculator. 2 times 2 is 4. 4 times another 2 is 8. We have 8 equals 5x minus 17. Now solve for x. And when I add the 17 over, I get 25 equals 5x, which leads me to dividing by 5, so 5 equals x. Okay, so let's plug that in, make sure that's a good solution. So remember, we're plugging in 5 here, so 5 times 5 is 25. We have 25 minus 17. Okay, is that going to give me a negative log? No, it is not. So we're good to go. Moving on, we have the natural log of 4x minus 1, which equals 3. Remember, natural log has a base e. So that's what I'm going to write first. That's my big number, base e. And this is my exponent. So e to the third power equals 4x minus 1. E to the third is something you will have to put in the calculator. Remember, e is like pi. It is an irrational number. So e to the third power is equal to, I'm going to round to the thousandths place, 20 and 86 thousandths, which equals 4x minus 1. Because I'm solving for x, I need to add the 1 over. Well, that'll give me 21 and 86 thousandths, which equals 4x, which now I need to divide by 4 to get the value of x. Because I am approximating, I do need to make this an equivalent symbol. X is about 5 and 21 thousandths. Okay, so let's check to make sure that will not give me a negative log. Okay, so if I go ahead and plug it back into my original equation, we have 4 times 5.021 minus 1 5.021 minus 1 and we want that to equal 3, which that's not going to give me a negative. I will still have a positive, so we should be good to go there. Okay, so this will involve some of last week's stuff. We have log 2 of x plus log x minus 5, which equals 2. Since we have that plus in there, we need to think back. Okay, how can I condense this into one log? Okay. And so remember, plus comes from multiplication. So I have log, I'm going to change it to just one log, of 2x times x minus 5, which should equal 2. Okay, so when I distribute that, I will have log, and if we want to go ahead and put the base 10 in there, because it is known that it is a base 10 if there is no number for your base. And when I distribute, I get 2x squared minus 10x, which equals 2. Okay, so base of 10, exponent of 2 equals what's inside the parentheses, 2x squared minus 10x. All right, so this is a quadratic. We're going to have to solve a quadratic by factoring, quadratic formula, graph it, find the x-intercepts. I'm going to do it by factoring because it is factorable. So to do that, I need to set it equal to 0. So this is 100. I'm going to move it to the other side by subtracting. So I'm going to have 0 equals 2x squared minus 10x minus 100. And before I start factoring, I'm going to have to look for a common factor, which there is a 2. So if I divide all of this by 2 and all this by 2, I get 0 equals x squared minus 5x minus 50. AC method. We have a 1 for the A, and we have a negative 50 for the C. So 1 times negative 50, which is negative 50. What would multiply to get negative 50, but add to make negative 5? I know, negative 10 and positive 5. Since your A is 1, that's what's going to be in the parentheses with the x. So, x minus 10 and x plus 5. And that all equals 0. Okay, so when I set each of these equal to 0, x minus 10 equals 0, x plus 5 equals 0, I get x equals 10 and x equals negative 5. Well, I gotta check those boogers. I gotta make sure they're not gonna give me a negative here. Okay, so let's look at 10 way up here at the beginning. So 10 will give me a 20 here, and it'll give me a 5 here. So I won't have any negative logs. That's a good sign. So 10 is good. Negative 5 will give me a negative 10 here. That is no bueno. Okay, so looking at my solutions, I do need to mark out x equals negative 5. X equals 10 is my only true solution. Okay. All right, so we got a log on the left and some logs on the right. Well, the log on the left is a log base 4, and the ones on the right are a log base 4. But we should condense the one on the right, yes. So the left one is still log base 4 of 2x plus 1, that's good, equals log base 4, but this subtraction means that it was division. We can condense it to division. Okay, so we're going to have x plus 2 over 3. Okay, now this becomes very simple. We have log base 4 and log base 4, so what's inside the parentheses has to be equal. 2x plus 1 has to equal x plus 2 over 3. I know many of you do not like to work with fractions. If you don't like to work with fractions, multiply with the denominator. Let's multiply by 3 on both sides. Now that 3 cancels out that 3. And then now I need to distribute this. So 6x plus 3 equals x plus 2. We've got a simple algebra problem here. I'm going to move this x over here. I have 5x plus 3 equals 2. Then if I subtract the 3 over, that'll be 2 minus 3, that's negative 1. Okay, and when I divide by 5, x is going to be equal to negative 1/5. Let's see if that really works. So if I put in a negative 1/5 here, that's going to multiply by 2 and get negative 2/5 plus 1. Oh, that's still going to be positive. That's good. Okay, over here, negative 1/5 plus 2, that's going to still be positive. That's good. So x equals negative 1/5 is a good fit. Great solution. Let's use it. The end.